Hi, I am Yasar Arafath. I am here with another maths video for class 10 CBSE students. I welcome all of you to this video. Trigonometry. So you can just revise the trigonometric ratios, 6 trigonometric ratios. So I shall draw a triangle here, K, P, K, M. Okay. So a right triangle here. So we want to just revise 6 trigonometric ratios. So first one is we fix an angle, suppose K. So what will be sine K in this triangle?
PM by MK.
PM by, right? PM by MK, right? PM by MK, because PM is the side opposite to angle K, divided by hypotenuse is MK. Okay. What is cos K in this picture?
PK by AM.
PK by KM, KM or MK, no problem. Then tan K, what is tan K in this picture?
PM by PK.
PM by PK.
PM by PK, right? PM by PK, opposite side by adjacent side. Okay, then 3 more ratios are there. What's the next one? The inverse or reciprocal of sine K. What was the reciprocal of?
Cosecant.
Yes, cosecant. Cosecant in short we can write cosec. Cosec K is equal to, what will come?
MK by PM.
MK by PM. Just to take the reciprocal of this. So MK will come in the numerator, that is hypotenuse divided by opposite side. Okay, then what was the reciprocal of cos K?
Secant.
Yes, secant, in short we can write sec K. Sec K, how will come?
MK by PK.
MK by PK, good. Okay, so hypotenuse divided by adjacent side. Then what was the reciprocal of tan K?
Cotangent.
Cotangent. Cotangent of angle K, in short, cot K is equal to PK by,
PM.
yes, PK by PM. Okay, so that is adjacent side by opposite side. Okay, now we move to some of the property. I think from this picture itself we can make some remarks here. Okay, so look here, sine K. Sine is defined as opposite side of an acute angle divided by the hypotenuse. So may I ask you a question? Can the value of sine be more than 1? Can?
No,
Yeah. No, right? Why you said no?
because hypotenuse will be always greater than other two sides.
Yes, right. Okay. In a right triangle, the hypotenuse is the largest side. So if we take any acute angle, so the opposite side divided by hypotenuse, the numerator will be less than the denominator, because denominator is hypotenuse. So we know a fraction having higher denominator will be always less than 1, right? So the sine K will be less than 1. It cannot be more than 1. So what about cos K? Can it be more than 1?
No.
No, right? Cos K also same reason, because here also the denominator is hypotenuse, that is largest side of a right triangle. So a small quantity divided by a large quantity will be always less than 1. Okay, there are some special cases. In some special cases this sine K will become 1, and some other special case sine K will become 0. These two special cases we will discuss in detail later, not in today's lesson, but this today you keep this in your mind. Sine of an acute angle will be always less than 1. Okay, so the sine function, sine at this operation, the sine is defined for acute angle right now. Maybe in higher classes you will also study the sine values of obtuse angle and higher number, sine 400, sine 300, at same time sine minus 100, sine minus 90, etc. Okay, so this time we are defined this for only some acute angle. So for an acute angle inside a right triangle, we can say the sine value is greater than 0 and less than 1. Okay, sine value for an acute angle will be greater than 0 and less than 1. So we move to some other, okay, we want to make this idea, these trigonometric ratios more clear. So for that, I'll draw two right triangles here. First one, I'll draw like this. The second one, suppose this angle, I simply take x. Okay, so with the same angle, I draw some other right triangle with the same angle, with a different size. Suppose this angle is also x degree. So x is a acute angle. So I drew two right triangles with the same angle, same acute angle. So the third angle will be equal, right? If two angles are equal, then the third angles will be equal. So I give name ABC for the first triangle and some other name PQR for the second triangle. Two triangles with the same angles. Okay, so x degree, x degree. Okay, their size are different. Their size are different. So what we are going to look is, we want to check whether the sine values of this angle x is equal in both triangles. And what about the other trigonometric ratios? Are they same? Are they equal? Even the size are different. That's what we want to look now. Okay, so we can apply the similarity idea. So here, since two angles are equal by AA criterion, these two triangles will be similar, right? Triangle ABC will be similar to triangle PQR because their two angles are equal, 90 degree, 90 degree, x degree, x degree. The third angle will be also equal. So we can also say by AA similarity criterion or AA criterion, these two right triangles will be similar, not congruent, similar. Their angles are equal, their size are not equal. Okay, so we can apply the similarity, the ratios of corresponding sides are equal. So how will come? So you can start with the small side. So BC by QR, right? The smallest side, so we have taken first. Then the middle side AB by PQ. Okay. Then the largest side, that is hypotenuse, AC by PR. AC by PR. Okay. So what we have written is, since these two triangles are similar, we can write their corresponding sides are in same ratio by the definition of similarity, similar triangles. Okay, so BC by QR will be equal to AB by PQ, that is equal to AC by PR. Okay, so we take first one and the third one. First one and third one, that is BC by QR is equal to AC by PR. We just rearrange this. So we make same sides of same triangle in one side. Okay, so AC we move to left side and then QR we move to right side. So how change? BC by AC, right? This numerator, this AC in the numerator, when you move to left, it will come in the denominator. It's equal to this QR, you move to right side. So QR
by PR.
in the numerator, right? QR by PR. Okay. So with respect to angle X, in the first triangle, what is BC by AC? Which trigonometric ratio?
Sine.
Sine, right? Sine angle X, right?
Yes.
Sine X is opposite side of that angle X divided by hypotenuse, that is BC by AC. So for BC by AC, we can write as sine X is equal to, in second right triangle, what is QR by PR? Which trigonometric ratio?
Sine x.
Sine X, right? Sine X. Okay. So you can write here sine X. Okay. So these two angles are equal, and we have found that sine values of these two equal angles are equal even though their size are different, their sine values are equal. Okay, sine x. In other terms, you can say sine A in the first triangle is equal to sine P in the second triangle if angle A is equal to angle P. If angle A is equal to angle P, then sine A and sine P are equal. Okay, so next we can take a first one and the middle one. So same way we want to make BC by QR is equal to AB by PQ. AB by PQ. What will come if we do the same way? BC by AB is equal to, right, QR by PQ. So what is BC by AB? Which trigonometry ratio with respect to angle X in the first triangle?
Tan X.
BC by AB is tan A. Okay, tan A or tan X. I think better we can write it tan A is equal to what is QR by PQ in the second triangle?
Tan P.
Tan P, right? So we have taken angle A is equal to angle P. Angle A is equal to angle P. We have seen that tan A is equal to tan P. These trigonometric ratios of this same angle in these two triangles of different size are equal. Okay, and one more, last one. We choose the second and third one. AB by PQ is equal to B by PQ is equal to AC by PR. You do the same way. AB by
AC
is equal to
PQ by
PR. What is AB by AC with respect to angle X in the first triangle? Cos A, right? So cos A is equal to, in second triangle, what is PQ by PR?
Cos P.
Cos P. So yes, right. Okay. So from this problem, or from this, I think we can generalize some ideas. Okay. So here sin A is equal to sin P, and tan A is equal to tan P, and cos A is equal to cos P. If you just take their reciprocal, so we can also see that cosec A is equal to cosec P, and sec A is equal to sec P, and cot A is equal to cot P. Okay, I don't do that here. From this, I think we can get it. Okay, so what we generalize from this picture is, for an acute angle, the sine value of that acute angle will be always equal. Whatever the size of the right triangle may be, the sine value of an acute angle will be always a same quantity. We can say that is a constant number. So suppose this x value is 45 degree. Suppose this x value is 45 degree, then sine 45 will be a constant number. There will be no change. Okay, and tan 45 will be a constant number. I know, so this tan 45 is 1. Tan 45 is 1. So we can make some tables of sine values and tan value, cos value. So because for an acute angle, the sine values, cos values, these trigonometric ratios are same everywhere. Okay, whatever the size of the right triangle may be. So tan 45 is always 1. So if we know this number, if we know the ratio of some angle, actually we can do some reverse question. Okay, so that's what comes in the next chapter. So just for some curiosity, I will show a problem. In the next chapter, application of trigonometry, we will see more questions like so. Suppose this is Qutub Minar, and one man is standing here, and he is looking to the top of the Qutub Minar. Okay, suppose the picture is like this. A triangle can be formed. This is Qutub Minar, and a man is standing here. Okay, and he is seeing the top of the Qutub Minar at an angle 45 degree. Using some clinometer, we can measure the angle. We'll see in the coming chapter. Okay, so if it is sure that this is 45 degree, then suppose we give name, this length, the distance AB and the height BP will be same. So it is enough to check this length AB. You measure AB through the ground. So if you calculate this distance, that will be the same for big P, because we know tan 45 is equal to 1. Tan 45 is equal to 1 means BP by AB is equal to 1. So if we got AB, we can substitute here so that we can find out BP. So similar problem we will discuss in detail in the next chapter. I was telling you this because if you take a small right triangle with one angle is 45 degree, okay, in this triangle also the tan 45 will be 1. And in the large triangle with one side as Qutub Minar, here also tan 45 is 1.